Hi everyone, I am Belal Hussain from the University of British Columbia. This talk is about statistical methods to deal with differential treatment non-adherence in pragmatic trials with point treatment settings. This joint work is done with Dr. Karim and the work is supported by the BC Support Unit. Pragmatic trials are designed to generate real-world evidence to guide decision making in real-world settings. In many trials, the participants in the control group do not have access to the treatment, so that there is no non-adherence issue in the control group. However, there could be incomplete adherence in the treatment group due to side effect, for example, which makes analyzing pragmatic trial data challenging. Naive methods such as intention to treat, naive per protocol, and naive as treated methods are usually not recommended to deal with incomplete adherence in pragmatic trials. The inverse probability weighted per protocol, or IPW, and instrumental variable or IV-based methods such as 2SLS, 2SRI, and relatively new IV method, the NPCB, can be used to deal with non-adherence in pragmatic trials, but they require different untestable assumptions. For example, the IPW method assumes no unmeasured confounding, while IV methods assume the instrument is associated with the outcome only through the treatment, which is also known as exclusion restriction. In this study, we aim to compare the performance of IPW and 3 IV methods to deal with differential non-adherence in pragmatic trials for point treatment settings. We followed 2 established simulation structures with 3 settings that are shown in diagram B, C, and D respectively. Setting 1 is nearly an ideal situation where exclusion restriction is satisfied, and adjusting only for measured confounder can give unbiased estimates. For setting 2, there is unmeasured confounding present, and for setting 3, the exclusion restriction is violated. Risk difference was the target parameter, and we compared the methods in terms of bias, standard error, mean squared error, and 95% confidence interval coverage probability. Our simulation scenarios include 10 to 90% non-adherence rate, weak and strong confounding related to U in the diagram, and null and non-null treatment effects. We simulated 1000 samples per arm and considered 1000 iterations for each scenario. As a case study, we analyzed 2-arm randomized control trial data after addressing the differential non-adherence issue. Here we show the results for strong confounding for a non-null scenario. For setting 1, the IPW method performs very well in terms of bias and coverage for any non-adherence rate. But 2SLS and 2SRI methods have high bias and poor coverage beyond 60% non-adherence. As expected, the IPW estimates are biased for setting 2, and 2SLS and 2SRI estimates are highly biased for setting 3. Since NPCB gives only bound estimates, bias cannot be computed. However, the bounds are very wide in all scenarios, but as expected, the coverage probability is always 1 for this method. In our case study using the IPW, we observed 5 fewer deaths per 1000 children in the treatment arm. The estimate was around 3 per 1000 using 2SLS and 2SRI. The difference in estimates might be indicative of the presence of unmeasured confounding as we observed in our simulation setting. Also, the bounds for NPCB is very wide, which is also consistent with our simulation results. The overall conclusion of this study is fairly simple. We need to be cautious using the IPW when there is strong unmeasured confounding, and avoid using 2SLS and 2SRI methods when exclusion restriction assumption is violated or there is high differential non-adherence rate. That's all for today. To know more about my research, you can email me at belal.hussain@ubc.ca. Thanks everyone for watching this presentation.